Hi and welcome to Axiom Chemistry. This video is the first in the lab series and discusses the solubility of sodium chloride in water. Now, you're probably familiar with the idea of putting sugar into a hot drink or salt into a soup or a stew, and you've probably noticed that the crystals seem to disappear when you do that. After a while, you can't see them anymore because they've dissolved into the liquid. We talked about that in the video about particles, and in this video we're going to investigate just how much sodium chloride, that's what ordinary table salt is, how much of it can dissolve in water at different temperatures. But we're going to begin by reviewing the relevant health and safety issues. Before starting any Axiom Chemistry lab, the Axiom Chemistry lab health and safety document must be read and understood. If you haven't read this yet, then you should pause the video and do that now. And then, perhaps obviously, during all labs, students and supervisors should adhere to the health and safety guidelines outlined in this document. And then during this lab, eye protection and a lab coat or apron must be worn. That's of course to protect your eyes and your clothes. Your eye protection might be some safety glasses like these, and the lab coat or apron, well, that could be just an ordinary household kitchen apron. Also, suitable precautions should be taken when heating water and when pouring hot water. So, for example, if you're using an electric kettle, make sure it's in good condition. It's not leaking and the cable isn't frayed. Or if you're using a pan on the stove, well, be sure you don't touch any naked flames or hot surfaces. Okay, with that in mind, let's take a look at the equipment and the chemicals you're going to need for this experiment. They are, of course, all listed in the Axiom Chemistry lab equipment and consumables list. And here they are. You'll need insulated beakers. They need to be larger than 100 millilitres. You're also going to need a thermometer, a stirring rod or a spoon. This can be an ordinary kitchen spoon. A glass or beaker that's larger than 150 millilitres, so bigger than these insulated ones. A digital scale, a measuring jug, and then also some means of heating water, so you could use a small pan on the stove or perhaps an electric kettle. In addition to that, you're going to need distilled water, some ice, and then sodium chloride, which is just plain salt. That's ordinary salt that you eat. Okay, if you haven't yet gathered those items, you might want to pause the video and do that now. At the end of this video, I'm going to show you two optional further investigations. If you want to do those, here's what else you're going to need. Some vegetable oil, isopropyl rubbing alcohol, nail polish remover, sugar, and Epsom salts. But you can wait to the end of the main lab to decide whether or not you're going to do them, so there's no need to gather those extra things right now. Okay, let's now take a look at a typical lab report. Then you'll know what you're going to have to do, and also how you can go about writing up the report for yourself. A lab report should always start with a title, and mine is The Solubility of Sodium Chloride in Water. Then you need either a goal, what you're trying to achieve, or a hypothesis, what you think will happen. And I've written a hypothesis which reads, the mass of sodium chloride that will dissolve in a given volume of water will vary with temperature. Next, you need a method. This will describe how to achieve your goal or how to test your hypothesis, and it should be accompanied by a neatly drawn diagram in pencil. So let's take a look at my method. So first of all, a glass was part filled with ice and then completely filled with distilled water. Next, 34 grams of salt was added to an insulated beaker. In a moment, I'll show you how to measure out this 34 grams. And then 100 millilitres of the now chilled distilled water was poured into the insulated beaker and stirred until all of the salt had dissolved. This 100 millilitres is measured using your measuring jug. But how do you know when all of the salt has dissolved? Well, it can be a little hard to be sure when you've reached that point. But if you've given it a good stir and then removed your spoon or your stirring rod, and if the water is clear and you can't see any crystals at the bottom, well, then probably all of the salt has dissolved. Before we move on, I just want to show you my diagram that goes with this method. So first of all, my beaker, which I just draw very simply like that, and I label it. I then mark the level of the water that's got sodium chloride in it and also label that. And then I'm just going to sketch in a spoon as well that I use for stirring. Before we move on, I just want to show you some photos of this experimental setup so that you're absolutely sure what it is that I'm describing to you. So first of all, here is a glass and you can see it's got the distilled water in it and then also some pieces of ice. Now, you might ask, why use distilled water if this ordinary ice here is going to melt into it? Well, that is a very good point. It is actually better to use ice that's been made from distilled water. But actually the amount of ice which is going to melt into the distilled water is pretty small, so it's not going to significantly impact your results. So there's my distilled water with the ice in it, and that's just to chill the water. In fact, you can see here that the water has been chilled down to 5.5 degrees Celsius. Now, room temperature is usually around about 23, 24, maybe 25 degrees Celsius. Of course, it's going to vary. So you can see that this water has been significantly chilled. Of course, I'm also going to need some sodium chloride, which, as I've said, is just ordinary plain salt, the kind of salt you eat. And I'm going to need a mass balance. You can see that this mass balance is reading 0, and that's because I've pushed this button here, the tare button. That zeros the scale. So now you might be wondering, well, how do I measure out exactly 34 grams of this plain salt into an insulated beaker? Well, let me show you. You take your insulated beaker, here's mine, and you put it onto the pan of your mass balance. And then you press this button here, the tare button. That will zero the scale. Then you very carefully add this plain salt to the beaker until you get to exactly 34 grams. Okay, so let's go back to our method now that we've found out how to get 34 grams of salt into our beaker. So we've done this part, and then, as I said, you just use your measuring jug to put that chilled distilled water into the beaker, and then you stir it until all of the salt has dissolved. So what do you do next? Well, a further 0.5 grams of salt was added to the beaker, and the solution stirred. Just want to show you how to measure out that 0.5 grams. There are actually two ways you could do it. You could just put your insulated beaker back onto your mass balance, back onto the pan, and then slowly sprinkle salt into it until you've reached 0.5 grams. The only problem with that is if you overshoot. So if you put more than 0.5 grams in, well, you can't take any out. So I'm actually going to show you another method. Once again, you need your mass balance, which you want to 0. And then you want to put on it a little piece of paper, which you folded in half. So you can see that here. I've again pressed this button, so it's on a 0 on the scale. Then you carefully pour salt onto the piece of paper, like this. You can see here, there's a little pile of salt here, and you can see that I've got exactly 0.5 grams on my piece of paper. At that point, you just need to pick the salt up and pour it into the beaker. But the good thing about this method is if you put too much salt on here, well, you can just take it off until you've got the right amount. And so you don't get too much when you then pick up the paper and pour it into the beaker. You can see the salt just being poured into the beaker right here. So let's go back to the method. So we've just seen that a further 0.5 grams of salt was added to the beaker and the solution stirred. So then, if all of the salt had dissolved, this step was repeated until no more salt would dissolve. So if it had all dissolved, another 0.5 grams of salt was added to the beaker and the solution stirred. And then once again, if all of it had dissolved, you'd add another 0.5 grams of salt and so on until everything had dissolved. And only at that point can you move on. The temperature of the solution was recorded. So at that point, when you're seeing sodium chloride crystals or salt crystals remaining at the bottom of the beaker, you then put your thermometer into the beaker and you measure the temperature. Okay, that's the first part of the lab. What do you do next? Well, 34 grams of salt was added to another insulated beaker. Use exactly the same method as I showed you a moment ago. 100 millilitres of distilled water at room temperature was poured into the beaker and then stirred. So you use your measuring jug to measure out this water and you pour it in and then you stir it. A further 0.5 grams of salt, again I've shown you how to do this, was added to the beaker and the solution stirred. If all of the salt had dissolved, this step was repeated until no more salt would dissolve. And then the temperature of the solution was recorded. You'll see that this part of the lab here is pretty much the same as this part of the lab here. The only difference is that you're starting with water at a different temperature. You use chilled water here and then water at room temperature here. and you actually repeat it 3 more times. The process was repeated with gently heated, strongly heated and freshly boiled distilled water. That's where your kettle or small pan on the stove come in. And you want to kind of spread your temperatures out a little bit so that you're going to get a nice spread in your results. So that's the full method. You can see that you're repeating this process 5 times with the chilled water, the room temperature water, the gently heated, strongly heated, and then freshly boiled distilled water. So that's what you do. Now let's turn to the next part of the lab report, which is the results. And the results for this will be the final water temperature measured in degrees Celsius and the mass of the sodium chloride added, which is measured in grams. And I'm going to put that in a little table. So first, let me show you my final water temperatures. My chilled water was at 6.6 degrees Celsius. That's my room temperature. And then these are my warmer and warmer temperatures. I do want you to notice that the maximum temperature that I recorded was a lot less than the boiling point of water, which is 100 degrees Celsius. And that's because the water cooled during the experiment. And that's why we measure the temperature at the end, not the start of the process. We want to know the temperature when we've finished doing this lab. And now I'm going to show you the masses of sodium chloride that I added. So that was my first one, just 34.5. And here's the rest of my data. And you can see that as the final water temperature was increasing, the mass of sodium chloride added was also increasing. You can see that even more clearly if I plot that data on a graph. So here's the graph of the data. You can see I've given it a title. I've also labelled my axes. So my x-axis is the final water temperature, and I put the unit, degrees Celsius. And then the y-axis is the mass of sodium chloride added. And again, I've noted the units, which are grams. And then I've neatly plotted my 5 data points on the graph. And it's very, very easy to see that the higher that water temperature, the greater the mass of the sodium chloride added. So those are my results. The last thing that should be in your lab report is a conclusion. And the conclusion should always link back to your goal or your hypothesis. As a reminder, my hypothesis read, the mass of sodium chloride that will dissolve in a given volume of water will vary with temperature. And of course, that is exactly what we saw. So I could write, the mass of sodium chloride which dissolves in a given volume of water increases with temperature. But is there anything else that I can write in my conclusion? Well, one thing which is always good to think about is experimental limitations, which could lead to inaccuracies or errors in your results. So, for example, I could write, inaccuracies in the results came from not adding exactly 0.5 grams of sodium chloride between observations, inaccuracies in measuring the volume and the final temperature of the water, and difficulty in determining whether or not all the salt crystals had dissolved. So that's the end of the first Axiom Chemistry lab. Now, of course, you should have a go at doing it for yourself. And don't forget, a well-conducted lab includes both careful practical work and a well-written report. Just before we end this video, let me show you some optional further investigations which you could complete. So first, how does sodium chloride dissolve in other solvents? Well, you could repeat the experiment at room temperature using vegetable oil, rubbing alcohol, or nail polish remover instead of distilled water. But please don't heat these solvents because that could be dangerous. And then second, how do other solutes dissolve in distilled water? You could repeat the experiment, but rather than changing the water temperature, you could change the solute. So you could compare the solubility of sugar or Epsom salts to that of sodium chloride. And this could be done at room temperature or using warmed water. So there you are, 2 further investigations for you to complete if you'd like to explore solubility in a little bit more detail. Well done, and see you in the next video.